Hey everyone, today I want to talk about motor heat. Basically, I want to compare the different motors. I want to see how quickly they overheat, how they all stack up. We have quite a bit of options nowadays. We've got the CannonCore, we got the Superflux in different versions, we got the GT motor or the Hypercore basically, which is the same for Pint, XR, and GT. And then we have the new GTS motor. So I just wanted to see how those different motors stack up and in general how the different boards stack up. Unfortunately, I don't have all of them in VESC boards, but I do have two GTSs that I can use to compare. So I will run those up this gnarly hill, basically here. Let's take a look at that. So this hill right here, and I'll show you some aerial footage of it too. This is an absolute torture hill, but the key is it is doable. It is even doable on the GTS, possibly on the GT. I know my son can make it up on the GT. I don't know if I can. I will try that out. But yeah, that hill is basically a total monster and a challenge for any setup. And just about a year ago, I never even thought of going up and down this hill, but I discovered that it connects to some of my favorite trails. And so it's actually a great way of dropping into some of the trails. Basically, the way we want to do this is we're going to ride. I prefer to watch the board than to watch my face. All right, we'll go down this a little bit, but this is actually not a test run right now. And it's not hot enough yet either. It's only 70 right now, but it heats up during the day, so air temperatures right now are around 80, and they are supposed to stay the same all week, which is perfect for doing back-to-back runs and apples-to-apples comparisons. We will see how the temperature is doing, and then what you will see is I was only wanting to really compare the motors, but one of the big problems is that as soon as the motors don't overheat, then the controllers become the challenge. So I will run down and then back up this hill with each of the boards that I'm comparing, and we'll see how far they get or how far the temperature gets. Alrighty, so here is board number 1, and this is the Floatwheel ADV. It is actually the first board that I took up this trail. It was by accident that my wife was leading me onto this trail when we were walking the dog, and so I was stuck at the bottom. I was like, oh damn it, I gotta get up here. And yeah, so I worked my way up, and it actually overheated several times. It's overheated the controller really bad, and it turned out that it was because I had opened up the controller box so many times that the thermal pads that are used for cooling it down, they got damaged, or they basically disappeared. So without thermal pads, the float wheel didn't stand a chance against this hill, so I had to take several breaks, and it was painful. But anyway, and then after I did it with the float wheel, I was like, all right, well, I can just use this trail or this big ski slope as a regular part of my rides. And yeah, so I've tried it with pretty much all my boards since. One of the reasons I was very hesitant to try it with any future motion board is that before they had gradient tracking, you would tail drag on this. You had no way to make it down safely. And I think back then we didn't have custom shaping for the GT, and so you couldn't lower the nose or anything like that. So there was no way to even trick it to make it work, and so it was just too dangerous. And then it wasn't till GTS came out and gradient tracking that I started trying this. So I will definitely take the GTSs down and up this, and I know that it works. I've already done it. I am getting a GT now as well, so I will try it too, but I'm a little bit more worried about the GT, but I'll probably make it down, but we'll see how it is on the way up. Anyway, so we are now at the start of the hill test. We can see the controller is already pretty toasty. 49, that is 120 in Fahrenheit. So let's go and get up there. All right, starting it. You can see how quickly the controller cools down, which is basically due to the fact that these controllers don't have big heat sinks. Oh yeah, I should also mention this uphill has fairly loose dirt on it, and so it is quite a challenge, and I need to have all my focus, it requires all my focus for me to make it up here without skidding out and digging a giant hole into the dirt. So I hope I will make it. I've skidded out here so many times, so I really gotta keep my eye on the ball to finesse my way up here. This section here is usually the most critical one, and I made it. All right. Oh no, there's more. Okay. Looking good. One thing that's really nice about riding a Vesk board up this is that you constantly are aware of what your temperatures are. You don't have to stop or nearly stop to see it by going deep into like the settings and diagnostics menu. So yeah, right now I think I saw 148 or something for the controller, and here is a flat section in the center of that big climb, so the controller is getting a chance to cool down. And when I tested the Floatwheel just the other day, but I screwed up the filming of it, so I have to do it over. It handled it just fine. Also, just for the record, temperature right now 79 out here. All right, I gotta be focused. This is another good spot to skid out, and as you can see, the stock tire of the Floatwheel doesn't exactly have the best tread for this kind of climbing, but it works. I've made it up before. So, and where are we in terms of Celsius? 55 and 62. Also, with the Vesk logging abilities, we can obviously just do these runs and I can show you the final logs, and you don't actually have to watch me go up this stupid hill. But we don't have that option with the future motion board, so I have to constantly try to click on the settings, and here we go. All right, so similar results as the other day, 66 or so for the MOSFETs, and if we switch to Fahrenheit, come on, press and hold, there we go. Yeah, so also motor temperatures tend to be quite delayed. That's just the way how the temperature sensor is positioned in the stator. It sits on the Hall sensor board, so it doesn't actually touch the hot phase wires. So the actual heat on the phases is usually quite a bit higher than what's measured, and the heat still spreads through the whole assembly. So that's why you tend to get like 10 seconds or so of climbing temperatures after you're done doing the hard stuff. But yeah, that was the Floatwheel.